Oh, sorry. Betul, betul, betul. Yup. Shut up. See, I hate everything related to Gemini because it hears my shit. I hate it. Yup. Is my audio okay? Shut up. See, I hate everything related to Gemini because it hears my shit. I hate it. Yup. It's the chat. See, the shut. I hate. No, shut. Okay, one more thing I need to check. Yup. Okay. Today's plan is suffering more. Let's inform to the world that we are suffering. Twitter. I don't know, man. Twitter, the content I see like my For You page in Twitter has kind of become very boring. Let's suffering while creating. Oh, developing a transformer. Please help. And then hit up with the shit. How do you hit it up? Do we give us our YouTube? I should learn how to create a YouTube notification. Wait, let's do that first. Let's try to automate this entire YouTube notifications. Go to studio. Let's do this. Okay. I have a subscriber. Amazing. I have 1 subscriber. This is amazing. This is so cool. Me getting 1 subscriber. Views is basically just me. 333, all 3 of them on me. Where's the YouTube? Where's the Twitter? Content. What is this? Live. Ah, okay. We do have a lot of live content. Copyright? No. Wait, what is the copyright? See details. Show me copyright. What is copyright? Wait, if it's just me humming, I'll be so pissed. No, maybe this is the. Oh yeah, right. I reacted to videos in this. Okay, fine. I don't care. I mean, I do care, but hey, what can we do about it now? How do you set the thing? Channels. Upload defaults. No. Close. How do we do it? How do you do it, bro? Dashboard. To everyone who sees this, there you go. I have nobody. So sad. How do you set Twitter notifications? So let's go. How to set Twitter notifications for YouTube. Stream. How to automate? No. Yeah, how to automate your go live notification.
Hey everyone, it's Jordy aka Mrs. Relicious here, and welcome to the very first quick.
Don't care. Yeah, show me this.
Okay, so that covers Discord. Next up is Twitter. For that, we're gonna go to ifttt.com, which is another free service. If you haven't already, be sure to sign.
No, never mind. We'll just do something like this. Okay. Je ne care pas. You might know. There you go. Anyone who wants to come to my channel, please come. I'm streaming over here. All help is appreciated. Twitter. Suffering from developing a transformer. Please help. Post. There you go. Please help me. Wow, I wish I had a cute family. Okay, oh well. Where were we? Yeah. Yesterday I was tinkering with our project which we have, and we have reached this situation. Our application is breaking. I don't know how it's breaking, why it's breaking, but it is breaking. The error that's raised over here is operation subject has no shape. Yeah. So this is where I'm stuck. I don't know why is it an operation subject showing that something is breaking, because I'm not creating an operations. It's an input mat, and there's no operation subject has no attribute shape. That's another thing. I don't know what does that mean. What does this mean? Operation object has no shape. You know, a cool application that has been created in this world. You know what? Go do this. Control C. Here, enter. Then go here. Where was it breaking from? And no, not encode. Sorry. Main.py. Train. Then this is throwing an error. Please fix this. Very cool way to do it. Oh, I am très stupid. Très. There was no self. My god, selves. We needed the self. Oh my days, bro. Oh my days. Now it should probably work. Yeah, another thing I'm planning today is, you know what? Once this is running, we will do a little bit of DSA. Yesterday I was doing a DSA competition. You know, the lead codes, the code chef contest that was happening. I sucked. It was not like how I used to be in the good old days, like 5 years ago, 4 years ago, 5 years ago. Yeah, I used to be like actual peak. You know, in Valorant terms, I used to be like high diamond. And what's it called? Yeah. In league terms, I used to be like at least emerald diamond. Oh my, I used to be peak. And yesterday I was trying to solve a simple DSA. It was like a graph, I believe, graph question. Bro, I sucked. I looked at the question, I was like, what the fuck is this talking about? It's like, no, I cannot. What is this? Oh, sorry. CD transformer. Oh my, name this. F2 transformer. Python main.py. You fuck. Oh, yep. And then, you know, this is amazing to me. 5 people viewed my thing. Can I see who are the 5 people? Because I cannot believe 5 people are viewing my thing. Dude, that was so hype. I'm so happy to see 5 people. 2 people. Oh my god. 2 people are viewing my things. No way. No way. It has to be a bot. Human, can you please view my thing? Say hi. Human, is human there? No, that's not human. Oh, I was caught for a second, just for a second. I was like, oh, a human actually watching my thing. Then bam. Wait, does stream elements give you a chat? Who knows? But bro, I saw 2 over there. I was so hyped. Yeah, something like this. 5 people. No way 5 people are viewing my things. Oh my days. Oh my days. Okay, let's go. Come back to the problem in hand. So yeah, I was talking about competitive programming. Bro, I have lost my touch on everything about DSL. Even simple algorithms like what's it called? Dijkstra's, your prims, your Kruskal, Union Find, Kostraju. I suck at all of them. So right now the stream will be mostly just focused on doing that. So let's like change the stream title, like name it, whereas settings. Can we change it from here? Channel content, details, no. Learning, relearning, data structures, and Algo. Running transformer in the background. Save. Shitty stuff. Oh my god. The research paper, I hate that research paper. That research paper is the worst research paper I've ever seen. It makes me angry in it. Now this will break somewhere, but we'll look into that a little later. Today our goal is trying to learn these. Like these questions were pretty easy. The green ones have already done it. They're pretty easy ones. BFS, DFS, pretty easy. Now we're going to learn about Dijkstra, topological, Kruskals, Bellman, all these cool stuff. Okay. I know the problem. Yep. Let's do this. Find the shortest path. Okay. Check if node is reachable from every other node in the tree. So if a node is reachable, so how do we make that a node is reachable? First, distance. So let's build up our initial idea of what Dijkstra is. We know what is Dijkstra. Yeah. So let's do Dijkstra. Let's think about what Dijkstra is. Off topic, in 4 days. My university results have then come. Oh my god, I don't know what I'll do. I get my university results. I will die from cancer. Oh, I'm stressed out, like super stressed out from that, bro. Because it's like only one exam. It's a pass or fail. Hopefully, I pass in all the 4 exams. Oh, thinking about it gives my head a ache. Oh, save me, somebody. I just want to graduate so fast. Okay. I'm sorry that I have to check my stream every time because my net is very bad, so I have to always check if my stream is crashing or not. Okay, so sorry for that. And also I'm running on a laptop, so I do not have the ability to check the chat every time. So that's another reason why. Maybe I can do something like this. Like, I don't know how to pop this out. Pop out chat. Oh, 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 oh. Oh, this is very cool. This is something cool I've learned. Okay. Okay. We learn things. Learn more. Okay. How do you close this? I don't know, but this is good. This is good. Yeah, this is good. This is an intervention. Voila. Pop out chat. Yep. This is perfect. This is something new we have learned today. Something else. Reactions is great. Community moderation. I cannot add moderators. Default. What is this? Comments on. This is fine. How do I remove that? Never mind. Wait. Okay, this is great. This is good. This is great. We'll keep you like over here. Okay, so first extract. Oh man, let me just bring my glass of water. Oh, my head is filled with distractions. 1 minute. Fine summer day. Okay, let's go with Dijkstra. So what is Dijkstra? Dijkstra is Does anything happen in here? Nothing exists. So Dijkstra is, suppose you have like one circle, another circle, another circle, and another circle, and we have a path from here to here. We have path from here to here. We have a path from here to here. Let's say we have another circle as well. Okay. Then we have a path from here to here. Path from here to here. Here to here. Here to here. Here to here. Let's say this has a cost of 2, 1. Oh my god. 5, 3, 1, 6, 4, 4. And if this is your S and this is your T, what we will do is we'll start from S So the idea is, first we'll choose the smallest out of these. Initially all of this will be infinite, so this will be infinite. Oh my, drawing with this is so hard. Infinite, 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 infinite. So first we take this smallest out of all of this, which is this path. Okay, and then we update this weight to this 1. So it's like 0. So this is like by default 0, 0 plus 1, 1. So now this thing's weight is 1. Then we find the, so this is now visited. So visited, we mark it with a yellow color X. Okay, so that's visited. We find the next smallest value, which is like 1. So we visited 1. So now we have options 2, 5, and then getting this T, we get this 5. This 5 and this 5. Okay. There are 2 options you can take. You can take this option, this path, or you can take this path. So let's say he takes this path. Okay. Then this thing's data is updated to 5, and we have visited this. Okay. So now shortest path from S to this point is 5. Shortest path from this to this point is 1. Shortest path from next smallest distance value is, oh sorry, you have this 2. My bad. We go to 2 next. Yeah. We update this one's data to 2, and we mark this as visited. Then we see the next closest, which is 2 plus 1, 3. So this is the next closest path. No, we calculate distance from like wait, I forgot the extra. We have 1, so we go to this particular point because this is the shortest point. So now we visit. Okay, so the extra is visit the node that is closest. So we have already added S to our set. So that's, we have in our set, we have explored S. Now let's call this as A. Now we explore A. After we explore A, what do we get? From A, we know this path, this has already been visited, so we don't include this. This path is there, it's not visited yet. So now this thing's data is updated to 4. Now every node has some cost. This one's cost is infinite, this one's cost is infinite, this one's cost is 4. So now we check the next shortest path from S. From next shortest path from S is, we have 2. This is visited, this is not visited, this is not visited. So next shortest path from S that is not visited is this. Let's call this as B. Okay, so B is not visited, so what we do, we add B into our system. Okay, so this gets removed and it's updated to 2. Wait. Is Dijkstra like, initially we add the weights of the smallest of the neighbor to its like the source will know the cost to its neighbor, so the neighbor's weights will be updated and the rest of the weights will hold. So now, first step, what happens is this one's weight gets updated to 1. So all the neighbors' weights will be updated. This one's weight will be updated to 2. This one's weight will be updated to 5. Okay. Next, out of these 3 neighbors, we find the neighbor with the lowest cost, which is 1. So we take this path. Okay. So now this is the new node from where we're going to start exploring. From this node, we find that the neighbors S is already visited. So visitor will like color it maybe. Okay. So this node is already visited. Now from 1 we are visiting 1's children. S is already visited. We call this as A. T is left, so we visit T from here. And we update its weight to now 5. Okay. 1 plus 4, 5, which is greater than infinite. So is infinite greater than 4 plus 1? No. So minimum of those two, which is 5. So now we have visited all children of A, and T also we have visited. Now we find the next smallest. We have 5, 2, and 5 again. Out of these, which is the smallest? 2. So now we visit from this node. Let's call this node as B. Okay. B. From B, we can, who are the neighbors? S is already visited, S is already visited. So we can go either to T or to this particular, let's call this node as C. Okay. So from B, you can either go to T or to C. If you were to go to B, our cost would be 2 plus 6. 2 plus 6, is that lesser than 5 or not? That is not less than 5 because 8 is greater than 5. So this path will not be, this value will not be changed. 5 will remain as 5. But to C, our cost is 2 plus 1, 3. So this path will be taken and your value will now be updated to 3. And we have visited all nodes of B. Now we go to the next smallest, which is C. C is the node with the smallest weight. So now we go to C. From C, we visit C's children. B is visited. There's T and there is this. Let's call this D. Okay. You can go to T and the cost will be 3 plus 4, which is 7. But 7 is greater than 5, so we do not take this path. So this path is not taken. Then we have to D. To D, we have 3 plus 3, 6. Now 6 is obviously greater than 5, so we don't change this path, this cost. So we have the shortest path, so we have shortest weight to this path as well and to this path as well. And we have visited this node. The other nodes, both of them same cost, so it does not matter in which order. So we have visited this, we have visited this. So in our heap, or the data structure we're storing your data, is going to be something like this. S, okay, first make it black. S, A, B, C, D, T, or TD, whatever. But yeah, this, and everyone will have their cost mapped accordingly. So if you were to think in that perspective, we need to have a heap. Now first we have to create our graphs. Okay, so what we do is have a graph. Then for U, or for edge in edges, What is n and what is m? N is number of edges and n is number of vertices and m is number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it seems like that. For I in range of n, the graph of I is equal to list. For edge in edges, graph of edge of 0 is equal to dot append edge of 1 and one equal to 0. So now we have our graph ready. Now given our graph, you write test is equal to is that a list comprehension? Wait. Dictionary comprehension Python. It seems to be like it. Okay, and then test of src equal to 0. C is equal to 0. Then what we do is we have a queue, because this is basically like doing DFS. From every node you visit every child, and then we have our visited set. Okay, so we have our visited, it's going to be a set, and visited dot add rc. Okay, then first we are going to basically visiting every node from this. So from S we visit all the 3 and update their weights. So Q is equal to initially src comma 0. No, that's not have src comma 0, let's just have src. Then while Q vertex is equal to Q dot pop 0, then we know what we do. Then we visit its children. Just like for node in graph of src, we check if node not in visited and no, first if 1 plus says dot max size minus 1. If 1 plus dist of src is less than dist of node, then dist of node is equal to 1 plus dist of src. No, 1 plus vertex c control v. Okay, so we find the weight of every node with its child nodes. Then what we do is we add all of them. Then into our queue we find the min weight. Okay. So what we've done till now is we have assigned weights. So this has now a weight, this has a weight, this has a weight. All of them have a weight to it. We need to find the node weight. Oh, we can use a heap for this. Import heap queue. This is the best thing of Python. They have such nice way. C++ has STLs, but STL I don't. I never found STL easy to understand. It is computationally better, but I have never understood STL. Yeah. So we have our main heap. Then we write and node not in visitor. Okay. Heap queue dot heap push into min heap your dist of node, comma, dist of node, comma, node. And then finally we do is we add all of them. Then we write q dot append heap q dot heap pop from min heap its first value. Okay. I think this should do the trick. Python. Yeah. Oh. Import says import heap key. Pop. Too many values to unpack. Or is it just this much? Do the amount of ads, close on ads. Shit, bro, the amount of ads is crazy. Thank you. Wait. Shit. Stop this.
Hi there, this is Robin Andrews from CompuAcademy, and this is a roundup of some excellent beginner Python resources. So if you're just starting to learn Python, these will be some excellent places to look. So the first one is called Hour of Python Trinket. So if you type in Hour of Python.
Who the fuck is it? Well, I love help. So don't
into Google or your favorite browser and click on through. It will take you to this page, and you want to go for the free lessons Python with turtles.
My god, that scared the shit out of me. Bro, shut up.
And this is what you get.
Dude,
So
no,
this is a great resource. It's got embedded.
You want to speak, just shut up. One, two, 1, 2, 3, 3, 4, 4. Is that the answer expected? 1, 2, 1, 2, 3, 3, 4, 4. Did I solve this? It'll be amazing if I solve this. Because, dude, remembering things is the most hardest for me. Then have this. Like dir for I in dist. If for I in range of n, d error if dist of I is equal to sys dot max size minus 1, then darr dot append minus 1, else darr dot append dist of I. Return darr. Submit. Please run, oh my god, please run. Huh? Now I need the fuck. Why did it take a long period of time? Isn't this it? Algorithm. Uh, what do we have? We have over here. Oh my god. Main dist is going to be sys dot max size minus 1 plus 1. Then so if this we just write if no, but we do need the thing we need. Oh, this is approaching in a different way. This is for all the elements, not just for the node. So what this is saying is that it doesn't matter. Yeah, I must have solved it somewhere. But coding is extremely boring for those who don't know. My god, the strength I need to do this is amazing. It is so boring. Like, I don't know how people actually like sit and like solve these. Like, there are people genuinely enjoy doing TSA. I don't know. Like, building stuff is also fun, but after like, for me, after like 10 minutes, I fall asleep. I just can't. My body just can't do it. The extra, they may do. Ah, having a queue is shit. Main heap dot heap push 0 comma src main heap heap q dot heap pop main heap comma d then we won't be needing this. Visited dot add vertex, we needing this either. This took a longer amount of time. 난데요. What I'm referring from is my own code, okay? So don't hate on me. Ho 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 ho. See, I told you I forgot like almost everything about coding. I forgot. No. See. We run. Hmm. You know, GFG, they need to change their UI and everything. The UI sucks ass. Unlike lead code, they should have a print and std output page as well. Okay, it is breaking. Where is it breaking? But oh, my bad. D, comma vertex. Now if I want to run it, yeah. D, comma vertex. Now run it. Now it should work just fine. Yep. Right. No. 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 You stupid bitch. Times n. Return test. Does this have? I don't know. Je ne sais pas. Pas je ne sais. Okay, submit. You fuck. Oh yes. What if we just put? Hmm. No one bowling in the chat. Refresh. Refresh. No. No pretense. Dude, this is so painful. This is so boring. I just want to die. I want a job. Job is the utmost importance to us. What is the difference between the two? Dude, what? Dude, what? What was there to do? Isn't that just Dijkstra? Is there something more in Dijkstra they don't know? How do I increase? How do I remove the 1.26 speed? Like, how do I reduce my application to 1.26 speed? Hmm? 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 And 1 plus dist of vertex is less than dist of node. Fuck you. Not fuck you. Run, 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 my child, run. Fly. Fly. Bro, nice. Nice. Uh, I don't want to debate about it. I have solved it. Great. Next, implement topological sort. Let's go. We have finished Dijkstra's. This is so boring. Take me out. What the fuck? What is the issue still there? What is it now? I removed it. Oh. Wait. Cross. It's like self leads. Line 7. does tensor dot shape always give a square is give a square matrix? Alright. So we have a vector? No. No. We have a vector? Who gives a fuck about a vector, bro? Whether it be a matrix. Well, vector size 512. Hmm. Hmm. Yeah. Where were we? Topological sort, right? How many of these yellows are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my god, 10, 11. 10 yellows are left. Uh, this is not an algo. Let's cut corners. Not an algo. Make it white. Right. Algo. Kind of an algo. Algo. No, an algo. Not an algo. No. We'll try to complete DSA within this month. I mean, at least graphs. Then next month we'll do heaps, then DP. Topological sort. Given an adjacency directed graph, return topological sort of a given graph. So you have an adjacency list given and we have children. So this is like basically if you were to check in a 3D fashion, be something like this. So if you were to file new, so you have like 1, 2. It's like, you know, in chemistry there is the which compound was it? Methane. Yeah, methane. CH4. Yeah. So this is how it would look. Right. Methane, right? Methane has this kind of this. Methane looks something like this, and there's a fourth one, which you point by a triangle. Yeah. So this is the topology which they have shown the example. I'm going to check if that output 1 denotes that the order is valid. There are a few valid topological sorts. 1, 2, 3, 3, 2, 3, 1. Is it basically that you don't, there's no cycle? Wait. Is topological sort just an algorithm to check if there is a cycle? Not. What do you mean by valid linear ordering of nodes? Okay, so that means that in a directed graph, your last value will always be a node which will have no out edges, and the first node will always be the node with no in edges. Is that correct? The first node is the node. Yeah, okay, fine. Yeah, it's correct. Me, uh, so, 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 so. This is too hard, and I'm so lazy. Can anybody help? The chat running. Okay, it's running. Fine, great. One subscriber is only that. I have received a subscriber, which is so cool, so cool, so cool. Hmm. 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 Sorry for the distraction. I need to check one thing real quick. Mm. Mm-mm-mm. 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 Huh. Did this somewhat work? Okay, it's still running. It's still running. That's great news. How do we check if a topological sort is possible? We can do something like this: traverse through like normal DFS and add the node in the start and then delete the node at the end. How does that sound? Let's just understand this thing properly. Topological sort. Topological sort for directory sequence linear ordering words says that every directory edge u, x vertex u comes before v in the order. No topological sort for a graph is possible if the graph is not a DAG. Okay. So some things to note. Find the shortest path from the closest neighbor. Topological sort. Find the linear ordering of a graph such that for every edge u, v, u always comes before v. It is only useful in a directed acyclic graph. Okay, so if you do not find a directed acyclic graph, don't bother with this algorithm. This algorithm cannot be applied to that problem. Okay. Output of this is like, so like given an example, 5 you can go to 2 to 0, 4 you can go from 0 to 1, 3, so it goes like 5 2 3 1. No, 5 4 2 3 1 0, because why 1 and 0? These two will always be at the end. Why would these two always be at the end? Because they have no out d. So whichever, so things to note. Another thing to notice, every internal node in the linear ordering will have an in degree and an out degree greater than 0. All starting nodes will have an in degree of 0 and all ending nodes will have an in degree of 1. No, will have an out degree of 0. Well, YouTube is not what? No video to maintain. What the fuck do you mean by that? Refresh. My god. Wait, are you people having actually stupid stream then? Dude, this was so hype. Oh my days. Oh my days. Okay. Find the linear ordering of a graph. Forgive me for the poor graphics. It's because I'm running on my laptop and I'm very poor. Such that for every edge u comma v, u always comes before v. It is only useful in a directed acyclic graph. Okay, it is very choppy. This very choppy. Out degree of 0. Okay, now it's fine. It is appearing to be very choppy. I know. I saw it. Fine. Yeah. Topological sort. We will do topological sort today and we will close it and we'll mostly focus on this. But for DSA perspective, topological sort, Dijkstra and BFS, DFS. That's great. Tomorrow we will look into things like, or maybe tonight if I'm like bored, we'll do Kruskal and Prim's, Bellman, Ford, and Floyd. 4 algorithms. Tag is a special type of graph in which the edges is directed as a no cycle exists in the graph. For understanding why topological sort only exists for DAGs, let's first answer 2 questions. Why topological sort is not possible for graphs with undirected? This is due to the fact that undirected edges between 2 vertices means there's an edge from U to V as well as an edge from V to U. So you do not know who is the, you cannot do the linear ordering without cycles. Every node will have an in degree and out degree. Topological sort may not be unique. Okay, great. Okay, how do you do topological sort? Have a stack and a visited array. For each unvisited node in the graph, call the DFS function on the vertex as a parameter. In the DFS function, mark the vertex as visited and recursively call the DFS function for all unvisited neighbors. Once all the neighbors have been visited, push that vertex on top of the stack. After all vertices have been visited, pop elements from the stack and append them to the output list until the stack is empty. The resulting list will be a topological order of the stack. Okay. So initially, suppose you have 0. You add 0 to a stack. Then from 0 you do a DFS. You get nothing. Then you go to 1. From 1 you do a DFS, you get nothing. From 3 you do a DFS. You go to 1. And as 1 is already visited, you add 3 to the stack. Then you go to 2, 2, 3 is already visited, so you do not bother with it, so you just add 2. Then you go to 4, 1, 0 and 1 is already visited, so you add just 4 to the stack. Then 5 is 2 and 0 is also visited, so you just add 5 to the stack. And then you print all of them. This is so much work. Okay. Okay. I'm just losing my brain. Okay, just don't mind me. I have to change this. Aww. You know, I'll tell you something. Most of my followers, right, are like people who want like their business done. So not like I care. They're just people who want to sell their banners. So like I'll show you. It's nice for me to show that. I so badly want to show that. It's not nice. Good manners. The people who want to spread their business. I'm not interested in those kinds of people. I like friends. I started streaming because I like friends. I like talking to people. You know, in chat, people come and become angry at me and throw insults at me. That's so nice. I like people talking back to me, having a nice conversation, even if they're hating me. It's fun. Right now we're just having fun coding. Maybe one day, if I get some kind of part-time and if I can buy a controller, then I can play games. But most of the games I wish to play needs a controller. And also I got scammed of my money. I got scammed of like almost $3,000. I don't know how I got scammed, but I got scammed. Yeah. Well, what can we do? What can we do? It's just painful to watch myself. Oh, that's so sad. Yeah. So what he's doing is something like this. He has a DFS, def DFS, which has a start, then rewrite visited.add start for node in graph of start if DFS of node means if node not in visited hmm. We do this for every okay. V then for I in range of V DFS of I. Oh, huh. Oh, well. That ain't. Wait, what are we supposed to return? Just return the stack. I do not know what is happening outside. Don't even think of asking about me. I don't know whether the mic is able to catch up the fireworks, but yes, fireworks is going outside. Aha. So basically, what is topological sort? Topological sort is basically you're doing DFS, but you're checking if from every node, if every node is possible to reach from a node that is a child of some other node. Okay? So you have a starting node. Given a starting node, you should be able to visit all the child nodes from it. So that node will be a starting node and there will be no out degree from that. And then every other node you visit. Wait, I don't understand. How does the algorithm work? Start a DFS from 0 because it has 0 incoming nodes. Okay. Occurs. So the algorithm for logical sort algorithm is something like this. Find the node with the smallest number of out degree edges and mark it as visited and then perform a DFS on it. After that, add that vertex to the stack because they have been explored. Find the edges and do the same. every node visitor as visited. And from do the same DFS exploring and explore the nodes are not visited. Repeat this process until all nodes are visited. Finally, the stack that you get will be a linear order where the first set of nodes will be those with the smallest of out degree edges, and the last set of nodes will be the nodes with the smallest number of in degree. So basically what the sort is not sorting based on the values. The sort is sorting based on the hierarchy in a hill. So let's say all your elements are now like placed in a hill. So when you're placed on a hill, at a particular point you either look down or you can look up. Nodes that are at the bottom cannot look down because at the bottom ground there is nothing. But when you're in the middle, you can either look look to the ground, or look up. And similarly, values at the peak will will not have anything to look up to, but have things to look down to. So that's why it's called like it's topologically sorting, meaning sorting based on the elevation. And here elevation basically means that number of in degree and out degree. It's like topological algebra or algebraical topology. It's one of it's like a mathematical concept from what I know. So we know about this algorithm now. We have written about it. We have understood. Something to note about topological. Topological is only used for directed graphs. If you use it for undirected graph, it doesn't make sense. Second thing, what is topological? Topological basically means that try to do a DFS from every node. It is, in simple terms, do a DFS from every node. Visit the node that is not yet visited, because you have found that there is a node you can reach from this particular point. So you find a node that is supposed to be visited from this point, and then every time you finish an exploration of particular node, put it onto the stack saying that this node has been explored. Do that for every node. So rule number 1, perform DFS on every node. After you explore a node, mark them as visited. After you explore a particular topological node, push them on top of the stack. Okay. Yeah. Crystals. Crystal, I believe it is just I think I know what Crystal. There's the implementation part. Is me implementing? Because I know. Okay. I'll just paint it out. So crystal is basically, let's say we have some points. 1, 2. Okay. And we have lines. 1, 2, 3, 4, basically what Kruskal is saying is that given such a graph and each of them have their weights, let's say this has a weight of 5, this has a weight of 4, this has a weight of 3, this has a weight of 4, has a weight of 1, this has a weight of maybe 2, and this has, let's say, a weight of 30. What we basically do is we create another graph for this, suppose, and this graph we use using union find. First take all the edge weights, sort all the edge weights. After you sort all the edge weights, you find the edges which have the smallest weight. This is like, so when you're using spanning tree, right, you should understand that there are two concepts in spanning tree. One is cut edge and another is cut cycle property. Cut edge basically means that you're going to find the edge with the lowest cost. So you know that there's one edge, one vertex which is always going to belong in a spanning tree, From that vertex you find the edge with the lowest cost. After you find the edge with the lowest cost, then the end point, I mean you have the starting vertex and the ending vertex, which handle this, what's it called, this lowest cost vector. So that edge, that end point will now be a part of your spanning tree. Okay, so that's your cut edge property. Cycle property is that the edge with the largest weight in a cycle will be removed. It's not part of the minimum spanning tree. And what Kruskal's algorithm is that you sort all the edges. So you have edge weights. Sort all the edge weights. Then you do a union find algorithm on all the edge weights and you create a new graph. And whenever you take an edge, whenever you're adding an edge, after you add the edge, you check for cycle property. Means you check if a cycle is formed. If a cycle is formed, remove the edge with the largest weight. That is the algorithm for Kruskal's. And then the final tree you get is your minimum spanning tree. Prim's algorithm on the other hand, so that is Kruskal's. I'm not bothering me learning its implementation. Obviously it would help, so we'll just look through it. Okay, so first he does a union find, then here we check if a cycle is formed. If a cycle is formed, remove it. Okay. Prim's algorithm on the other hand is something like this. Rather than focus on cycle property, it focuses largely on the cut edge property, where you take a random starting vertex. From that random starting vertex, you find the edge with the you find all the neighboring edges for it, and then you take the edge with the smallest weight. After that, you take the edge with the smallest weight. Then from that end point, you again do the exploration, and you repeat this process. It's like similar to Dijkstra's, like very similar to Dijkstra's algorithm, but now instead of seeing the shortest path, we're seeing the shortest overall weight. Okay, that's Prim's and that is Kruskal's. If we can like check its implementations, though I don't wish to bother with it. Prim's Why don't I bother with it? Because everything can be solved with union find. Union find is the best algorithm. It can do everything. There's nothing union find can solve. This whole minimum spanning tree can be done using this what's it called, union find. It's just that Prim's algorithm is much faster. Implementation. I did not bother with it, but good to look at. Sort all the edges. Yeah, start from, so you find all the nodes with the closest edge weight, and after that you find the edge with the closest with the lowest weight. After you find the edge with the lowest weight, you check if edge is not visited. If edge is visited, add it to the stack, and then we do the cut set property, meaning that edge will now be part of our tree. So that's why he added it into our MST. And then total cost is basically like minimum cost actually found or not. So we add it to our tree, and then we explore its children, and push it into the stack or into the heap. Why do they add the v in the neighbor? It is for, like, in heaps does not handle equal to condition. Heaps need to have another comparer. Like if the first comparer is equal, then they compare on the second value, third value. Okay. Yeah. Prim me with this Timmy. Yeah, let's implement this rule. Let's implement Prim me with this Timmy. So what is Prim me with this Timmy? Zero 1 5. Okay. Edge from 0 to 1, cos 5. For edge and adjacent, do us graph of u comma v comma w edge. Graph of u. One minute. It's kind of windy over here. Yep. Now it's no longer windy, bro. It's no longer windy. What is happening? So this is shit, top tier shit. What is happening? What is happening? Okay. Are you people actually not able to see anything? Who is this you people? This is me, myself, and I. Me, myself, and I. Dude, I cannot believe I have 1 subscriber. I don't know who that 1 subscriber might be, but bro, I'm so happy. I have a subscriber. Let's go. Is equal to for I in a range of V, graph of I is equal to a list. Then for edge in adjacent, graph of edge of 0 dot append edge of 1 comma edge of 2. Similarly 0. Then we have a visitor. Then what do? We have our total, let's call it weight. We have our Q. QA import heap Q is going to be basically visited dot add 0 or node n we add the node with the lowest weight. So we pop the first value which has the smallest weight, and weight is the first comparator. That's weight comma node comma start. w comma v comma q, not. Then visitor dot add v and weight plus equal to w. Then for node comma weight in graph of v, heap q dot heap push into q, their weight comma node comma v. Weight and run this. Unhashable. Oh. Underscore comma underscore comma. Where else have I used? Control Shift F. Dot ship. 0,1,5, 1,2,3, 0,2, 2, 1. Remove this. Hmm. 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 What? 013. What was it? 2 with a cost of 1. W is 1. Hmm. Unhashable type list. The fuck? But this is like such shit building of the application. Like, what is this kind of input? And like this should like clearly indicate the input. Here is like 015, and here shows that onto you add v comma w to it, a list, which makes no sense. my god, like what the fuck's the problem? Hmm. 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 I don't get it. He's using union and find for this. It's just shit. Fuck you. Fuck you, bro. Who uses union and find for this? And that he would be using some like good quality code. Fuck you. Now what kind of input is this? I don't understand. From my point of view, I understood the concept. This is shit. Absolute shit. Like 100% just fucking shit. What the fuck was that? The input was not clear. These two will do like tomorrow. Did the code break somewhere else? Okay. Encoder.forward means main. Ah, yes. Wait, we also had tensor. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. Mm-hmm, mm-hmm. Yep, I believe that's it for the day. We have completed almost everything. That code will run for I don't know how long. Thank you for tuning in to my short stream. I stream for like how many? Yeah, for 2.5 hours. For my sanity, this is enough. Appreciate the good work. Ta-ta, bye-bye, good night. Peace, peace, peace.